Hello, hello everybody. Well, I'm addressing the students of Standard 9th. I've been assigned to teach the magnetic effects of electric current. Before I commence, I would like to touch upon some of the prerequisites or some of the concepts that are involved when we try and learn the magnetic effects of electric current. So that's it. So now we need to understand what is electric charge. Well, there are many things. I will go in an order. So first and foremost thing, what is electric charge? Okay, well, if you already know it, it's fine. And if you have known some definitions, that's also fine. But from my experience, I have selected and sometimes I have modified the definitions to suit the students of Standard 9th. So here it goes. Where will you find charge? Okay, if you ask a question to yourself, where is charge? Now, well, in your earlier days or in your earlier chapters, your teacher has made you to experience charge. Your teacher has made you to experience charge. How did your teacher make you to experience your charge? Well, the simplest experiment would be, well, you take a plastic comb and somebody who has got dry hair, of course, you can't experiment with me. Somebody who has dry hair, you comb it briskly several times. And then you, before you do that, you make small bits of paper, you keep it on the table, you comb your hair nicely and bring the comb near the paper. The paper, the torn paper, the small bits of paper, that will start getting attracted to the comb. Okay, so that's really an interesting phenomenon. Now here what has happened basically is, the comb, as you know, is a material, it's matter, and matter is made up of atoms, molecules, all that. And let's talk about atoms. Now atoms have got electrons which are loosely bound. So electrons are loosely bound. See, the nucleons are tightly bound and the innermost electrons are tightly bound to the atom. But there are some electrons which are loosely bound. Means you can easily remove them. That is what we call it as loosely bound. So when you comb your hair briskly, what is happening is, some of the electrons in your comb are pulled by your hair, and so your hair contains now more electrons than it usually had, and the comb now has got less number of electrons. The comb has now less number of electrons, and now we say the comb is positively charged. Why we call comb as positively charged? Because there are deficient number of electrons. Deficient number means, if you take atoms in the comb, there are equal number of protons and equal number of electrons. Now some of the electrons are gone. Protons will not go from the comb, right? They are tightly bound. So there is less number of electrons compared with the number of protons in the comb. And therefore comb has more number of protons, more number of positive charges, therefore, or less number of electrons, therefore comb is positively charged. Okay, and now when you bring this comb near bits of paper, it creates electric force, and because of which the bits of paper get attracted. Okay, so this was a very simple experiment which made us to understand what is charge. So therefore now we identify that there is charge. And another thing that we all have understood is, you see, when you take a subatomic particle such as an electron, okay, so this electron has got two properties. One is the inertial property inertial property, and this manifests in the form of mass of the electron, denoted by m. And the other property is charge of the electron, charge of the electron. Okay, so denoted by E minus, and you know its value is 1.6 into 10 to the power of minus 19 coulombs. Okay, if you don't know these coulombs and all, fine. At this stage, don't bother. What is important here is that you have to, if you understand that electron has got mass denoted by Me and electron has got charge denoted by E minus, that is sufficient. If you can understand more than this, it's good. But right, 9th standard level, well, if you have understood the electron has got two properties, that's fine. Okay, so now we know that we have just now understood two concepts. What are that? One is a charged body, because we call a body charged if it has excess or deficient number of electrons, and electron has two properties, mass and charge. Okay, now let's come to formal definition of charge. Formal definition of charge. So what is charge? So now that we have identified matter, there is matter. If there is matter, there are atoms, and if there are atoms, there are electrons. If there is matter, there are electrons or protons. Okay. In other words, you see, charge is an intrinsic property of matter. Intrinsic andra huttu guna. Andra when matter is formed, automatically charges, there are charges. So it is intrinsic, means huttu guna. Nobody has added charges to matter. When matter is born, automatically charge is born. That is what we call it as intrinsic. So charge is an intrinsic property of matter. Charge is an intrinsic property of matter. You please appreciate and understand. In physics, we are able to identify many things around us by its properties. We call a cat because it has the properties of a cat. So charge is an intrinsic property of matter. As we will now see, there are many properties. One of those properties of matter is charge. So what is special about this property, or what is significant about this property? The property, the charge is an intrinsic property of matter which produces electric field. Charge is an intrinsic property of matter which produces electric field around it, okay, or experiences, or what? It produces electric field and is also responsible for the production of magnetic field. Charge is responsible for the production of electric field as well as the production of magnetic field, and it also experiences electrical and magnetic effects, and it also experiences electric and magnetic effects. Okay, well, I will explain what I have said now. I hope you are able to capture what I have told. See, I am not writing it on the board, because those students who are alert and who want to learn will concentrate and learn properly. They would be absorbing what I am telling. But those are the students who simply want to sit there and say, I am going to study and I am going to write exams. For them, well, things are going to be difficult. So, and let me tell you, you have got to learn and you have to put efforts to learn. That efforts of yours will get converted into knowledge, and that knowledge is in your head. Okay, if you write something on the book, it is in the book. Okay, it's just in the book. In the examination or in the real world, when you want to use the knowledge, you cannot always go take the book and you cannot write an examination. So it is better that you develop your brain. Said that your brain contains knowledge. Okay, and so for that you have to be alert. So once again I repeat. Now as I am telling, you have to imagine. Charge is an intrinsic property of matter which produces electric and magnetic fields, which produces electric and magnetic fields, and also experiences magnetic and electrical effects. Okay, and the concept of charge, as I have just now told you, it is when a body has excess electrons, we call it as negatively charged body. If it has deficient number of electrons, we call it as positively charged body. So this is how the property of charge has been established. Okay, fine. Now here in the definition of the charge, I have used two concepts: electric field and magnetic field. Electric field and magnetic field. Okay, now let's understand this electric field. Now all of us know gravitational field, right? We all know gravitational field. See, now for example, if I take this body and if I leave my hand, it will accelerate downwards. It will accelerate downwards because there is gravitational force acting on this, m into g. Because of this force, this body is accelerating downwards. Its velocity in this direction is increasing because of gravitational force. Now if I keep this body anywhere in this room and leave my hand, it will experience force. So that means now at every point in this room, this body will experience force. Which force? Gravitational force. So then if every point in this room, wherever I keep this, if it experiences gravitational force, then I will say that there is gravitational field in this room. Vis-a-vis, that means at every point it experiences gravitational force. Therefore, this room I will call it as a room where the gravitational field exists. So therefore, field means what now here? It's a region where a body having mass experiences gravitational force. Similarly, if at all I will take this body, I will charge this body. Charge means I will remove some electrons by some means you will learn in your higher classes, or I will add some electrons to this. If I add electrons, it becomes positively charged. If I remove electrons, it becomes positively charged. If I add electrons, it becomes negatively charged. Now such a body, supposing I keep it any point in this room and I just keep it here and leave my hand. Now if the body is there only, its position did not change, okay, then I say there is no electric field here. Supposing I keep this body and I remove my hand, this body which is charged, if it slightly moves, or in other words, if there is change of motion of this body, then I say there is electric field. Then I say this region has electric field because this charged body experiences electric force. See, just now we conducted an experiment. Bits of paper was on the floor or on the table. You combed your hair, right? And then brought the comb near the bits of paper. The bits of paper got attracted by around the comb there was electric field. Around the comb there was electric field. And because of which the paper bits got attracted. Is that clear, students? So a region where the charged bodies experience electric force is called electric field. Okay, there are other definitions of that. We will come into it later on. But at this stage, you should be happy with this definition. Okay, that's it. See, students, these are all very intense concepts. It needs to be defined even more deeply, right? Then only it gets that's the proper way to do. But to give you a very deep definition, well, you need to know something more physics. At this stage, you do not know more physics. Therefore, to understand the physics of standard 9th and 10th, this definition suffices. But be aware, when you go to higher classes, you might come across definitions which are much more specific, much more profound than what I have said. Be aware about it. Okay. So I have defined now electric charge, I have defined electric field. Now magnetic field. Well, that is very simple. You see, what is, again, field is same. Field means a region. Now here you see, what is magnetic field? A region where the magnetic effects are felt. A region where magnetic effects are felt is called magnetic field. Okay. Now, for example, you hang a bar magnet. You hang a bar magnet from the ceiling. Okay. You have a bar magnet suspended from a ceiling. Okay. It is suspended, and then you gently leave your hand. So you see the bar magnet is aligned in some direction. The magnet is aligned in some direction, and all of you know it is along the north-south direction. It gets aligned. The bar magnet is aligned and it is suspended. Now what you do? You gently move this. You see, you give a small twist with this. Okay, that is this one, not my hand here. For this, you give a gentle twist. So if you give a gentle twist to this, this one will slightly rotate like this, and it will make some small angle theta. Small angle theta. Now, if you remove your hand, this the magnet which was slightly displaced, if you remove your hand, it will once again return back to its original position on its own. You don't turn it, you keep it like this, it will by itself come back to its original position. I hope all of you have observed this. If you have not observed, fine, but you trust me, it will happen like that. Now, my dear students, here you apply Newton's laws of motion, because wherever motion is there, you have to analyze it using Newton's laws of motion. When this bar magnet was in this position and you released your fingers, there was no mechanical force acting, there was no net mechanical force acting, correct? That is when you removed your hand. Or in other words, you don't see that there is some force acting on it. Okay, that is, you are not moving your fingers or something. So according to Newton's law, it should remain like that only, in that position. Right? Newton's first law says the body retains its state of motion unless acted upon by external agency called force. And here he meant force means net force or unbalanced force. So if you leave the magnet in its dislodged position and leave your hand, it will by itself come back to this position. Now, if it is come back to this original position by its own, there must be some other force that is acting. You are not forcing it, but there should be some other force which is forcing it to turn back to its original position. Okay? Now, you should all appreciate that a magnet will get affected by magnetic force. Of course, a magnet will also get affected by mechanical force. That is, if you turn the magnet, it will turn. Now, we are not turning it. So there must be magnetic force. Okay, that's why it has turned. Now, if you conduct this experiment anywhere in this room, you will see the same thing happening. That means in every point in this room, there is magnetic effect. And therefore, I conclude there is magnetic field in this room. And all of you know that Earth's magnetic effect is felt on all the points on the surface of the Earth. Okay, so therefore there is magnetic field. Now, well, all of you have played with the compass, the magnetic compass. So magnetic compass, a small needle which can freely move. It will get affected if you bring a bar magnet near it. So a compass needle will get affected when you bring a bar magnet near it, because the bar magnet creates a strong magnetic field around the compass needle. Therefore, the compass needle will deflect. So this is how you are able to identify a region where there is magnetic field. Well, students, I think I have made myself very clear with the concepts of what is charge, what is magnetic field, and what is electric field. Okay. Now let us come to this charge. Let us come to charge. Okay. Let us come to charge. I told you these are the properties of the charge. Fine. Now, let us try to understand this charge better. Better. Because, this is how you have to understand physics. Okay. So now, you see, if this charge, see I am showing a point here. This point, if I say, this point means it's a small particle. Assume it's a small particle. I am not telling electron or proton. Small particle. This particle has got two properties. What are the properties? It has got mass m and charge q. Charge q. Okay, right. And now if this charge is in rest, you know what is rest? Rest means it's a state of motion. Rest is a state of motion. That means the body or the particle will occupy the same position during an interval of time. It will occupy the same position during an interval of time with respect to a reference point. Then we say it is at rest. Okay. So now this charge is in the state of rest with respect to some point. Okay. So I will draw a frame. That is, say, usually we say y-axis and x-axis, and I will choose this point origin as the reference point. So with respect to this reference point, this is at rest. Now, my dear students, everywhere around this, there are electrical effects. That is, if you keep some other charged particle here, it will experience electric force. Therefore, I will call this region as electric field. Okay, fine. So there is electric field around a charge in rest. Now, supposing this charge starts moving with some speed v. The charge starts moving with some speed c. That means the charge starts moving with some speed. Then when the charge is moving with some speed v, then around this charge everywhere, okay, you will find electric field and also magnetic field. So a charge in motion, but here I have to say that it is moving with the uniform velocity. If the charge is moving with uniform velocity u, that is, it is moving with same, its speed is not changing, its direction is not changing. If a charge is moving like this, then we say it is moving with uniform velocity. Now you will have electric field and magnetic field around the charge. These are experimentally proved. These are experimentally proved, and further, there are very great scientists like Maxwell. They have established theory which will explain why there will be magnetic field and electric field around a charge. Okay, you will learn those things in the higher classes. So, what did I tell you now? If a charge is at rest in a frame of reference, then around it you have electric field. If this charge is moving with uniform velocity, around it you have electric field and magnetic field. Okay, fine? Yes. Okay, fine. Now, if this charge is not going with uniform velocity, but is accelerating, that is accelerating. Okay, it is accelerating. Okay, so then what happens? Well, around the charge there is electric and magnetic fields, no doubt. In addition to that, if it is accelerating, that means its velocity is changing. Its velocity is changing means what? Either the speed is changing or its direction is changing, or both are happening. Then we say it is accelerating. And if it is accelerating, here, okay, then there is something interesting that happens. This charge will start giving out electromagnetic radiations. Okay, electromagnetic radiations. Okay, now just try and understand. Electromagnetic radiations means they are waves. Okay, they are waves. Okay, now what is a wave? See, now you go to a pond. Okay, so you go to a pond, or something like that. So a pond where water is still, and then what you do? You drop a pebble here. Okay, then what do you see? You see that there will be ripples in the water. Correct? There will be ripples in the water. Okay. Now, Aram se understand this. What happened? this piece of the object which you have dropped, it had some energy. What energy? Potential energy, mgh. And when it entered the surface, when it entered the water, what happened? As it was coming down, its potential energy was decreasing, kinetic energy was increasing. Why? Its speed was increasing. So when it touched this water surface, some of this kinetic energy or some of the energy of this body is given to this water. I repeat, some of the energy of this is given to water, and from this point onwards, this energy, some part of the energy, not all the energy, some part of the energy starts moving on the surface of water. Okay. Now, if and what we see here, we say there is disturbance. The pond was still. You dropped a pebble. The medium. What is the medium? The water is the medium. The medium got disturbed. You created halchal. The medium got disturbed, and this disturbance started moving in all directions. I suppose you can see them. There will be ripples on all the directions. So, as the ripples are moving, if you have kept some paper balls here, if you have kept some paper balls here, these paper balls will also start oscillating. Okay, they will also start oscillating. And a body is oscillating means it has got kinetic energy. Here, of course, every body will have kinetic and potential energy. That means now a wave transports energy. And also there is a concept called momentum. So a wave transports energy and momentum. Okay. Now here you see, in this case, when a charge is accelerating, it will also create similar ripple as it is creating in water. But of course, you cannot see that. But you must trust me that just like how if you drop a pebble, there is ripples and waves moving. Similarly, when this charge is accelerating, there will be ripples in the atmosphere. So these ripples will not make the air to move. Okay, there are ripples which are electrical and magnetic in nature. Okay, and they will start moving, and that is called electromagnetic radiations. Okay, so just understand this. Don't start learning more about these things and all at this stage. You should get introduced to some things initially. And okay, this is what happens. A charge at rest, there is electric field. A charge in motion, there is electric charge in uniform motion or moving with uniform velocity. There is electric field and magnetic field around it. A charge which is accelerating, well, it radiates electromagnetic energy. That's all. Enough. Okay. So, because you see, this summarizes the concept of charge. Alright, friends? Well, so that is the first aspect. That is, I just wanted all of you to get these aspects of the charge, and I think I have I've explained this at the level of standard 9 students. Anyways, if there is any question in whatever I have explained, you can write the question and you can WhatsApp to me or you can mail to me. I will definitely respond to that. Okay? Right. I am here to make sure that you all learn and acquire knowledge. Okay? Okay. Now, we shall move on to the next important concept that we wanted, that of electric current. Okay, this has to be understood properly. Okay, electric current. So, to begin with, see, now you know charge. A comb is a charged body. Like that, you can have charged particles. Just like a comb is a charged body, you can have small particles which are charged. So, I can say this particle, of course, it has some mass m and it has charge q. Discharge Q. Now I will give one more symbol to this, Q minus. Q minus means it is negatively charged. Similarly, I can create one more particle and say this has got mass m, and I will write Q plus. Q plus means that particle has got positive charge. Okay? Then I will create a concept N1Q minus. So N1 stands for number. So N1 into Q stands for N1 number of charged particles, or here N1 number of negatively charged particles. Similarly, I can create N2 Q plus. Means N2 number of positively charged particles. Okay friends? N1 number of negatively charged particles, N1 number of positively charged particles. Now, this can have different magnitude. That means this can be 10 coulombs, 20 coulombs, or something like that. Any number. The charge Q can be of any value. Similarly, charge Q plus can also be of any value. Now, supposing charge Q has got, say, 2 coulombs. Charge Q has got, the value of charge Q is 2 coulombs. And N1 is, say, 10. So 10 into 2 coulombs. So this product gives you what? 20 coulombs. Okay. Similarly, supposing N2 is, say, 20, and charge Q is say something like around 3 coulombs. So 20 into 3 coulombs gives you N2 into Q plus gives you what? 60 coulombs of positive charge. This is 20 coulombs of negative charge. This is 60 coulombs of positive charge. Okay, I made myself clear. Now, it is also possible that Q minus can be having some magnitude 10 coulombs, and Q plus is also having magnitude 10 coulombs. So, it is possible that the magnitude of Q minus and magnitude of Q plus can be same, magnitude can be same, and N1 and N2 can also be same. It is quite possible. Okay, keep these things in mind. Okay, it is all these combinations are possible. Okay, well. So now these are the particle charges that I have just now defined. Now let's look at this point. Say I have some point A. This is point A, not charge. And say now here from this side, N1 Q minus charges are entering this point. What does this say? N1 Q minus charges are N1 Q minus charges are entering this point. And that is, its N1 Q point charges are moving like this. So they will move. So they are crossing this point. Okay, they are crossing this point. Okay. Now we say there is electric current at this point. Why there is electric current at this point? Because charges are moving across that point. Okay. Similarly, if I choose some other point B, and this time I will make N2 Q plus charges cross this point B. Then also I say there is electric current here, there is electric current here. At both these points there is electric current. Okay? The difference is when negative charges are crossing this point, okay, then the direction of the electric current is like this. And when positive charges are crossing like this, the direction of the electric current, see this I is the symbol for electric current. The direction of the electric current is same as the positive charges. It is the convention used. You please understand, convention used. See, in India, when we are traveling, we should travel to the left of the road. Okay, and that is the convention followed. But in USA, you will have to travel to the right of the road. That is the convention followed there. It's all. So, in the direction of positive charges, negative charges, it is fine. Okay, this is one aspect. Now, there is a concept called total charge and net charge. See, I have not yet defined any current. I have just told current will be like this. Now, don't say this is complete. There are not some things that you have to understand. What is this electric current? Okay. Now, you see here. Now, supposing you have this point, say some point C. Now, both N1 Q minus is also moving and is also moving. N1 Q minus is also moving simultaneously. See, that is simultaneously you have N2 Q plus also moving. That is, both the charges are moving simultaneously. N1 Q minus, N1 Q plus, both of them are moving simultaneously and crossing this point C. Okay. Now the question is, what is electric current here? What is electric current here? Okay. There. Now try and understand this. Now, what is the total charge? See, what is total charge? Total charge crossing the point C. So if you say what is the total charge crossing the point C, then it will be N1 Q minus plus N2 Q plus. So if you take this sum, then you will get total charge. Means you just have to add the charges. Now don't say minus and plus. Okay, I am adding the two charges, just like how you add marbles. But there is a concept. So this is total charges. There is a concept called net charge. Now try and understand this net charge. Okay. So what I will do here, I will give something like this. I will say the magnitude of negative charge. What I said? Magnitude of negative charge. I am using the symbol. It means magnitude. Is equal to the magnitude of the positive charge. See, magnitude of negative charge means, say, minus 10 coulombs. Minus 10 coulombs, magnitude of minus 10 coulombs is 10 coulombs. Magnitude of plus 10 coulomb charge. Magnitude of plus 10 coulomb charge is also 10 coulombs. Let's say magnitude, kappa, or the effect. So, I will say magnitude of both are equal to Q. Magnitude of both are equal to Q. Okay, now you see. So, with this convention, I will write N1 Q minus, N1 Q minus, N1 Q minus, I will have to write it as Q minus, I will write it as minus Q. Why minus Q? Because it is negative charge. Plus N2 Q plus. What is the magnitude of Q plus? It is Q only, plus Q. It is plus Q. Okay. So what will I get here? I will get minus N1Q plus N2Q. So this I will write it as Q is common. I will write it as N2 minus N1. I suppose it is clear. Okay. Now you see, what is this? What is this? This is net charge. So you will add the charges along with their sign convention. For negative charge it is minus, for positive charge it is plus. So when you add them along with the sign convention, okay, then we call it as net charge. If you simply add the total charges, then it becomes total number of charges. Is that okay, students? Okay, fine. Now, what I would like to say here is, now here you see N1 Q minus charges, N2 Q plus charges are crossing this point simultaneously. So now I will now use the concept of net charge. I will use the concept of net charge. So here that means now how many, what is the net charge that is crossing this point? Q into N2 minus N1 is the net charge crossing this point. Is that clear? Hello, is that clear? Q into N2 minus N1 is the net charge crossing this point, and if this net charge is not equal to 0, if this net charge is not equal to 0, then we say, if it is not equal to 0, then we say what? There is electric current. Then we say there is electric current flowing. See, if N2 is equal to N1, no electric current is flowing. Okay, but N2 is not equal to N1, then electric current is flowing. Is that clear? Okay, but still there is a question. N2 is not equal to N1. There is electric current flowing, correct? But what is the direction of electric current? That's a big question. So now you see, N2 is for positive charges, N1 is for negative charges. If N2 minus N1, if Q into N2 minus N1, you get a positive number. If you get a positive number, then the direction of current, will be what? The direction of current will be in this direction. Then the direction of current will be in this direction. But if N2 minus N1 is negative, then the direction of current will be like this. Convention. Is it clear? Hello, is it clear? So the direction of the current will depend upon the direction of the net charge. If the direction of the net charges, that is, if the number of positive charges crossing the point in this direction and the number of negative charges crossing this point in the same direction, if you are considering that, and now if the number of positive charges are more than the number of negative charges, then the net current got by Q into N2 minus N1 will be in the direction of the positive charges. But if this net charge is negative value, then the direction of the conventional current will be ulta. Keep that in mind. But that is not all. Okay. Now you see, students. Okay. Now there is another situation. The same point C. The same point C I am taking. Okay. Same point C I am taking. Now you see the situation. N1 Q minus charges are moving like this. Okay. N1 Q minus charges are moving like this. N1 Q plus are moving like this. Okay. Now what is the net charge crossing this point? Now watch out here. Not out here. See, that time when I added them like that, both of them were going in the same direction. Now they are going in the opposite direction. So therefore here, what is the net charge flowing about this point? See now, what will I write here? Again, same. The magnitude of Q minus and Q plus is Q. I was doing the same thing. Now you see this one, I write it as N1 Q minus, I write it as N1 into minus Q. And N2 Q, I write it as N2 into plus Q. Okay, same relation. But this is moving in ulta direction. N2Q, if you say this direction is positive direction, then this direction becomes ulta. Okay? Okay, this direction becomes ulta. So I'll write, because the direction, see, because now here I am going to write plus. Why I am writing plus sign? Because I will consider this direction as positive, so I'll write plus. Okay, I'll write plus. Okay, I'll write plus. And because N2Q is moving in ulta direction, I'll write minus. Okay, did you get it now, students? This one, this one. Now, what is the net charge crossing this point? Net charge crossing this point. Okay, so I will simply add these two. So I'll get here minus N1Q, because you see N1 into minus Q is minus N, so into plus 1 is minus into plus is minus. Then plus of minus N2 into Q, this term. So here plus into minus will be minus. So I'll get here minus N1Q minus N2Q. So that gives you a minus Q into N1 plus N2. Please appreciate, this is the net charge crossing this point. This is the net charge crossing this point. And net charge crossing this point, so N1 and N2 are just numbers. N1 and N2 are numbers, are positive numbers. They are telling you how many charges. How many charges will always be positive or zero. So this will be a positive number, this is negative. Okay. So therefore, the net charge that is crossing this point, this net charge, I will use the symbol delta Q. I will use the symbol delta Q means net charge. Net charge crossing this point is negative if you have taken this as positive. Okay? And therefore, the conventional current will be in this direction. The conventional current will be in this direction. Is that clear? Now please appreciate and understand these aspects very, very carefully. Okay? Because what I have seen in my experience as a teacher from past 30 years, at the high school level, that is 8, 9, 10, if you have learned some concepts wrongly, they will get stuck in your head. And when you come to 11th and 12th standard, when your teacher in 11th and 12th standard tries to correct those mistakes, it will not be so easily corrected. And it will not be so easily corrected. And therefore, you see many students who are very good students, brilliant students, who score very well in their high school examinations, will not be capable of doing better in any competitive examinations in the near future. So, you see, there are now coaching centers which coach the students for, coach them better, make them prepared for the competitive examinations in 11th and 12th standard and all. Primarily, what are they doing? They are ensuring the students learn the concepts properly. That is the first thing that they are doing. They are building that. So, they will not teach current as charges are flowing, that is current. No, you have to teach all this. Then only it is correctly taught and it will be useful for you in the near future. Okay? So, it may be slightly taxing. You are all wonderful students, you are brave students. You have to accept it and you must understand this. Okay? If you don't understand this now, don't worry. I am making a video of this. It's available to you. You watch it repeatedly. Then the concepts will be clear. If still you have doubt, you can ask a question to me by WhatsApp or email. Well, I can answer. And even nowadays, you can send a voice mail. Okay, voice message to me. I will decipher that and I will definitely help you with the right solution. Okay friends, be happy, enjoy learning. Okay, so I have explained to you the concept of net charge crossing a point constitutes electric current. I have not yet measured the electric current. Now you see, the electric current has to be measured. So what do we do? Now that we have created the concept of net charge. I suppose you understood from what all I said, net charge is what. Okay. Now we have to now see this is net charge. Net charge is crossing. Now if more number of net charges cross this point in small interval of time, in a small duration of time, if more net charges cross, then the strength of the current is more. If less number of net charges cross the point in the same interval of time, I am considering time, then small current is passing. That's all. Okay. So therefore, when I say I mathematically, it means, what does I mean? I means the strength of the electric current. And the strength of the electric current is delta Q, the net charges crossing a point or a surface in time delta T, in a small interval of time. Now, what I do, the net charges crossing the point per unit time in the same delta time, this gives you the strength of the electric current I. Okay, this measurement I am doing at some given time equal to t. That is, I am doing it at this instant, next instant. Therefore, I am using this symbol. I am doing it at some time t, or simply noted as this is done at some time t. That's the idea. Okay. Now, in higher classes, when you go, the same symbol they will write it like this. So they will use a small letter I, indicating it is instantaneous current or current measured at a particular instant of time, or the strength of the current measured at a particular instant of time, and that we will write it like this. This is not I into t. This means I is a function of time. That means what is the value of I at this instant of time. Okay, and this they write it as limit delta t tends to 0, delta q by delta t, and this is equal to dq by dt. Okay. Now, well students, this one, if you have not understood, it is okay. Just don't bother. But when you go to higher classes, your teacher will write current like this. Okay? Then don't start arguing yourself. In high school we did this, now we are doing this. Don't do that. Okay? You will learn that better. Okay? Now don't bother about this. I am just telling you, well, there are wonderful things still for you to learn in your higher classes. At the lower classes, understand these concepts correctly. Then you will understand the higher concepts or more deeper concepts in your higher classes. Okay, that's the whole idea behind me telling you all this. Alright friends, so these are the prerequisites for you to learn this chapter on magnetic effects of electric current, and I will be dealing with it in the next chapter. Thank you very much. So you can WhatsApp to me 9844118615. You can WhatsApp your doubts to this number, or you can send a mail to me to this address. Sudheer, that is my name, Murthy. Okay, so let me write it properly. SUDH, okay, EER, Sudheer Murthy, MURTHY, Sudheer Murthy. Okay, Sudheer Murthy. One, there is no space. Okay, dot feat, FEAT, feat. Okay, at the rate of gmail.com. So you can send it to this mail, or you can WhatsApp me your doubts. See, again, WhatsApping your doubts, you can write your doubts in paper. Just take a photo through the mobile and then send the photo of the question to me. Or in the WhatsApp, you have got a button, you just press it. You can you can voice your question and then record it, and you can send that voice message to me. Okay, so make it simple. I will definitely respond to you. Okay, so this is the prerequisites for learning this chapter. Okay, thank you very much.